Assalamualaikum and hello everyone. My name is Ahmad Azhar bin Darwis, and now I'll be presenting about the introduction. So some people may be wondering what is really mean by trusses. A truss is one of the important structure type in structural engineering because it helps engineer to solve the problem that involve the mass aspect. Based on our research on the internet, we have found that a truss is a structured system that consists of triangulated system of members that are connected to each other to accommodate sum of load. These members are classified as two force members because the force are delivered only at one end of the members, resulting in compression or tension. Because of their capacity to span great distance efficiently, they are frequently employed as bridge design. So these trusses we can calculate in two methods, which is method of joint and method of section. So the question is, in a construction site, a crane lift a giant metal pipe which have a load of 250 kilonewtons. The crane structure consists of some trusses members to accommodate the load, with the length of CB equal to 2 meters, DB equal to 4 meters, and BA equal to 3 meters, and the elevation of DB is 45 degrees. Determine the force that apply to each of the truss member of the crane. So for the basic theory and literature review, I will pass the presentation to Binhal bin Hajail.
My name is Binha bin Hajail. I'm the presenter for literature review. So literature review actually is about the show the article of study about the truss before this. So the first article is written by Lian Che and Li Ka Ho. The title is Truss Building Structure. It's an analysis report of truss bridge, written on 16 July 2016. So this research show joints of two members have to fit to each other as nicely as possible in order to become a stronger bridge. The reason behind is because during the load is added to the bridge, the load is able to distribute evenly from one member to another member, providing a stronger structure and produce a stable bridge. The second article is written by Fermonto Lianto, Rodi Trisno, Ridiwiguna. The title is The Truss Structure System. This article is International Journal of Civil Engineering and Technology, written on November 2018. This research show the truss structure system is very flexible in following the shape of the building, so that it is very wide and varied, both in terms of the structure, dimension and profiles of the truss and building structure materials, so that the truss structure play an important role in realizing the design forms of architects, especially roof construction, to maintain the strength, robustness and stability of the building. So this article show the truss is a building invent that allow the weight of a roof to be distributed to the outer walls for better support. So truss gives more support and allow the builders to use fewer materials to achieve any construction. It allows distribution of load. It increases the span means life span of any construction like bridge or building trusses. Trusses have some disadvantage also. In truss bridge, it takes up more space and can sometimes become a distraction to the drivers. It also have a higher maintenance demand of all joint and fitting, more calculation to determine that it will take the maximum bed. Determination of force is in member is carried out by two processes: method of joint and section. By this, we conclude force in each member and it each joint in trusses play a vital in our surrounding like bridge, in building, rooftop, and more in the others building.
Assalamualaikum and hi, my name is Afi Al-Hadi and now I will explain about the calculation. After we read the question, we must draw the FBD. After that, we use tan to find the theta, which is tan theta equal to 2 over 4 and the theta equal to 26.56 degree. And then we find the theta at the point C, which is 30 plus with the 26.56, and we will get the answer is 56.56 degree. Next, we apply cosine law to triangle ABC. We use b square equal to 2 square plus 3 square minus 2 bracket 2 times 3 cos bracket 30 degree plus 90 degree, and then we will get B equal to 4.356 meter. After that, we use sine law to find alpha and we got alpha equal to 23.413 degree. After we get every information on the FBD, we dissolve the force to Fx and Fy. At joint A, we find sum of force V, which is Fy equal to 0. FAC, FAC sin alpha equal to 250. Then we replace alpha with the value that we got. We will get FAC equal to 629.159 kN, which is in tension. After finish find Fy, we find Fx, which is Fab equal to Fac cos alpha. We replace the Fac cos alpha with the value that we got, and we will get Fab equal to 577.357 in compression. At joint B, firstly, we must dissolve the force to Fx and Fy. After that, we find Fy equal to 0. We find the FBC. FBC equal to 577.357 sin 30. And then we will get the FBC equal to 288.679 kilonewton in compression. After finish find Fy, we must find the Fx. Fx equal to 0. FBD equal to 577.357 cos 30 degree, and we will get the answer FBD equal to 500 kilonewton also in compression. Lastly, at joint C, we must dissolve the force to Fx and Fy. We find Fy equal to 0. We find FCD sin in bracket 30 degree plus theta plus FBC cos 30 degree equal to FAC sin 23.413. We replace the point theta and FBC with the answer that we get, and then we will get the answer with FCD equal to 0. After we finish find the Fy, we must find the Fx. Fx equal to 0. FCE plus 288.679 sin 30 degree equal to 629.11 and 59 cos 23.413. After that, we will get the FCE equal to 433.017 kilonewton in tension.
Hi, Assalamualaikum. My name is Muhammad Luqman Hakim bin Abdul Aziz, AA 211045, and now I will continue with discussion. So, the truss by method of joint that our group built is able to withstand 215 kilonewton of load by having three joints, a pinpoint and a roller. All joints are connected by wood with angle of joint A equal to 23.413 degree. joint B equal to 30 degree, and joint C equal to 56.56, 30, and 23.413 degree between the members at both ends of the truss. Firstly, we analyze the internal force by doing method of joint. There are two types of internal force, which are tension force and compression force. Tension force is maximum force that the crane can withstand before its break after being pulled or stretched. Meanwhile, compression force is the capacity of material or structure to withstand load tending to reduce size. So based on the model structure, the highest tension force is FAC equal to 629.159 kilonewton, while the highest compression force is FAB equal to 577.357 kilonewton. Furthermore, FBC equal to 288.679 kilonewton, which is compression. FBD equal to 500 kilonewton, which is compression. FCE equal to 433.017 kilonewton, which is tension. And FCD is zero force members. Zero force is a member, a single truss segment in a truss which given a specific load is at rest, neither in tension nor in compression. All the tension and compression force act on the crane is stabilized to support the weight when external vertical force are being placed on it. Hence, the crane does not break. So, as a conclusion, a truss is one of the important structure type in structural engineering. This project has allowed us to understand load distribution in a structure deeper as we were able to calculate and identify the type of force applying in each member. We explore different arrangement of structural members and realize it is important to identify the different force such as compression, tension, zero or critical in structural members in order to achieve a high effect crane design. So that's all from us. Thank you.